Hi guys, hope all of you are doing good. This is going to be my first tutorial on YouTube, so apologies for any inconvenience, and hopefully you can learn something new from this, and hopefully the method that I use is easy for you to follow, and you guys can, create something amazing of your own. Now, the effect that we're going to work on today is this sort of a sandpit effect. Now, this project was done for a client. So, and to be honest, I'm not sure if I'm supposed to be showing you this, but what the hell? Learning doesn't stop, eh? Right now, I've actually rendered out a couple of shots. I'm going to be going over how I did this in Houdini and a few tweaks that I used to render this out in Cinema 4D along with some troubleshooting tips as well. This is the same shot but from a top-down angle. Moving on, what I'm going to be showing you is my Houdini file. So as you can see, this is what the file looks like. I can imagine this whole node tree might look a little intimidating, but trust me, it's not. So the first thing that I did was I actually created a terrain which was pretty simple. I just used a couple of displacers inside of Cinema 4D to create this, and I ended up exporting an FBX for this terrain out. And the second thing is this alembic. Now, these are 3D models of certain structures, buildings that I bought off of the internet. So I won't be able to provide you with a 3D model for this, but I can provide you with the terrain because that is something that I built. And this alembic is already animated. If I scrub through, this is already animated, and I did this inside of Cinema 4D as well. Now, if we move forward, I'm just going to, take this alembic and pin it in the wall for a while we, prepare our collider geometry, which is going to be this. Now, for those of you who don't know, anything that you import from Cinema 4D comes in 100 times larger in Houdini. So you have to adjust your scale accordingly, which is exactly what I did over here. Just hooked up a transform node, scaled it down by 100, and after that I just gave it a color node. I just gave it a color node to, sort of change the color for the terrain. Uh, I did the same thing with an alembic. Now, for an alembic, you need to unpack it so that Houdini can read the actual points and the vertices and convert it into a shape which you can, into a geometry which you can use or tweak for your own goods. And I did the same thing, bar the convert and unpack node. And the next thing that I did was I gave it a color of white. Now, obviously, you're not seeing that because you have UV maps on here, but trust me, guys, it is white. After that, what I did was I sort of just froze this animation. I just used a time shift node to freeze this animation, and I used an attribute transfer to sort of just have the affected area where the buildings are coming out from on my actual terrain, because as you can see the whole terrain is like much bigger than the area where the buildings are coming out from. So I wouldn't want to use this whole terrain. I just ended up using this small area, and what that helped me did was I could actually, sort of isolate this area and play around with it. Moving on, and this is just a very simple attribute transfer setup where I just, by default, it just transfers all the attributes. But since I wanted to use color, I'll just put color in here so it does not end up transferring anything else. The other thing that I would want you to take a look at is under conditions, there are these little settings which which sort of, give you the ability to blend all of this in a bit better. The next thing that I ended up doing was I just simply blurred the color attribute, so just to smoothen the transfer of the color, to give it a bit more shape, give a bit more gradient. And once that was done, I plugged this into a point warp. Now, a point warp might look scary. It did to me at start, but trust me, it's not. If you know what you're doing, if the logic is clear to you, it's not that scary. It's just a visual replacement of Vex. And if point warp looks scary to you, then I can only assume how scary the wrangle or the Vex code might be. So moving on, I just plug this in. It's a very simple setup that I did was when you come into the point warp, you'll see these two windows, and these two windows are basically your inputs and your outputs. And all I did was I took my position, right? I put it through an add, and I plugged it back in. I'll just do this. Yeah, and I just took my P, ran it through an add node, and just plugged it back into my P, right? And now what we're actually looking to do is we're actually looking to displace this color, right? Either in positive y direction or the negative y direction, right? And for that, what I did was I took my color, right? I multiplied it with a constant, right? My color, which is already transferring the data as to what is going to be displaced and what is not going to be displaced. I multiplied that color with a constant. Now, another important thing to note over here is that this P is a three float is a three float vector, right? So it has an x, a y, and a z, and the same goes for color as well. That is why I had to use a three float vector as a constant, in which I can specify in which direction do you want me to move this isolated area. Now, if I wanted to move this in the x direction, I could have done that very easily, as you can see, right? Or something like this, where it's skewed, right? Let me just turn this off, where it's skewed towards the left. But because I did not want to skew this and just displace this in the y direction, I just simply multiplied it with the constant, with the x and z values being 0 and the y value being, whatever it is that I wanted to do. And I just added that with the current position and output it as my new position. Now, if you want to see the result, this was the before. I'll just plug my uh, I'll just plug my wireframe on again, and this is the after, right? So we've got our area, right? The next thing that I wanted to do was I actually wanted to delete all of the attributes, because now I'm going to be creating this geometry for collision, right? Uh, Once I was done with the attribute delete, like removing all the unnecessary attributes that I did not want, I ended up just creating a group node, right? And making sure the group type was set to edges, and include by edges was on, and just selected unshared edges. So it can, just select the boundary edge. And then I used a simple transform node to move that certain edge with the group obviously isolated over here. I moved that edge downwards, or, you can also call this, scaling along the edges downwards. And I just used a simple polyfill node to sort of create this into a thick geometry. And then I ran this through a collision source, which gave me a geo node and a VDB node. Now, these three things I had to do because this needed to be converted into a VDB. And if I didn't do any of this, and tried and convert this into a VDB, you see what that does. And that is primarily just because VDBs don't work on thin surfaces. They need a thickness, they need volume to be converted into a VDB. I'll just turn my cache on. Yeah, that is pretty much it for how I made my collider. Now moving back to how I made my grains, right? Uh, Same geometry, right? Yeah, there you go. Sorry. I should, uh, I should organize my file a bit better. All right, this geometry, all right, this part was a little tricky, and I saw this somewhere on the internet, but essentially what I wanted to do was I wanted to fill this area only with my sand particles. Now to do that, essentially what you would do is, and this is just something that I'm going to show you really quickly. So since this is a rubber toy, a very simple rubber toy, right? If I wanted to fill this rubber toy with points, I just take a uh, points from volume node, right? And what that's going to do is that it's gonna create a volume for this test geometry in the background and then just fill it up with points, as you can see, right? And that is the exact same thing that I want to do over here, right? But the problem is that this geometry, number one, is not thick, right? So you cannot create a volume out of it, which is why the points from volume would fail if I points from volume, right? It would essentially just end up scattering points on the surface. But that is not what I want. I just want to fill this whole volume and I want to fill it up till this path, right? This part. And another thing that I wanted to do was I want the points to follow sort of the terrain over here, right? And this, I saw this little trick, with the trick that I'm about to show you off of the internet, and whoever it is, credits to him, kudos to him. It was a clever trick, and it helped me solve this problem. So what I ended up doing was I ended up merging both of these surfaces together. So as you can see, they're merged together right now, right? And after that, I ran them through a fuse node, right? Where I didn't really meddle with these values. It might work for you or might not work for you because a lot of this is scale dependent. And when I ran this fuse through a VDB from polygons, right? Just give it a second. It ended up giving me, so what you'd see is this, right? But since I wanted to use a volume, what I ended up doing was I ended up turning this distance VDB off and turning on my fog volume, and it gave me exactly the area that I wanted. Now, you could theoretically do this with a Boolean as well, but from what I experienced, the isolation or the extraction of the area wasn't as clean as it was with this method, right? And once that is done, you run it through a points from volume, and you see your points being scattered onto that volume. And the most important thing is if I just quickly run this through a VDB from, excuse me, particles, I just decrease the minimum radius, you'll see that this actually follows the terrain of this actual geometry. So that is the biggest advantage that I got with this method, right? Now, once that is done, what I ended up doing was I just ended up selecting or grouping a layer of particles that are just on top, and I'll explain what happens when I do that or why did I do that. For now, let me just go through and explain how I did that, and I'll once we move forward with the tutorial, I'll teach you exactly why I did what I did. Now, what I did was from this part, right, from the attribute transfer, I just took a delete node and I ran an expression through a delete node, a simple expression at CD lesser than zero point 0.1 and sorry, yeah, at CD lesser than zero point 0.1, and what that did was it deleted everything which whose color was lesser than zero point 0.1. So I got this little patch of geometry. I know, ugly looking. I could have finessed this a lot, but well, I was running short on time, so I did not. Now, after that, I just converted this to a VDB. And yes, you can quote me on this. I told you that thin surfaces don't make VDBs, but once I ran this through a VDB from polygons and a VDB reshape, what that does is it sort of just gives it some thickness so you can actually see the geometry, and it works in this case. And I just gave this an offset, and this is just a very simple offset. It's basically just a measure for how thick do you want your VDB to be. And inside of my group node, what I did was I set it to points, right? And I enabled keep in bounding regions, and I set the bounding type to bounding volume, and I gave my VDB and to the second input as the bounding object. And what that did was it just selected all the particles that were coinciding with that certain VDB, and I just made a group as top particles, right? Now, once that was done, I used a split node, right? Basically just to split my two particles. So the particles that were coming from point from volume, and sorry, scratch that. So once I ran those through the top particles group, I just use a split node to split the top particles into a different stream, right? And once I did that, so as you can see, these are the particles that are splitted, right? The top particles, as we say, and these are the particles without the top particles, right? So now, don't worry, I'll explain exactly why I did that. So after I'm done with the splitting, I just ran a simple attribute wrangle. Don't get scared. This is just a state that I'm storing for these particles. Now, I means integer. Integer is any value. It can be any value, but it cannot have a decimal point. So it's 1, 2, 3, 4, 5, right? It cannot be 1.1, or it cannot be 2.576. It cannot be that value. That value would be a float. Integer is a simple whole number, as you would say, right? Integer at stopped is equal to 1. So what this does, it tells all of these particles to store a value as to store an attribute as stopped, and that would be equal to 1, right? So if I just come to my geometry spreadsheet, and you see all of these particles have this stopped attribute, which is 1. Another thing that I forgot. Another thing that I forgot. In my points from volume, I added the scale attribute. Now, just as a quick FYI, this is not an accurate representation. This is not an absolute scale value. This absolute p scale value. Uh, this actually is a scale for the distance between those two particles. So if I'll show you what I mean. If I just if I just show you those lit spheres. So you see how my particles are now in the form of lit spheres, right? Now if I decrease the point separation, if this was an absolute scale, right? What would happen is if I increase my point separation or decrease the number of points, the radius of these points should remain constant and the distance between them should increase, right? Theoretically, yes. But what you'll see is as I increase the point separation, the radius also increases, right? So now you understand what I meant when I said this wasn't an absolute scale, and rather it sort of from this is what I understood. I can be wrong, and please do correct me if I'm wrong in the comments. What I meant was this actually sees the distance between two particles and the scale it currently occupies and sort of calculates it along those lines, right? Now, coming back, set up just a simple attribute, I at stopped is equal to 1. Uh, this is important. So what I ended up doing was I just ended up creating an attribute noise, and it creates a simple noise for me, and it projects that noise onto any attribute that I want. Now I know that a DOP network or a POP solver can read the mass attribute, right? So what I ended up doing was I ended up creating a mass attribute, setting this to float, because this is definitely going to be a float value. Mass is not a vector, it's just a float. It only has one value. And I just played around with these values to give it a minimum value of 2.5 and a maximum value of 4. So the minimum mass that a particle will have is going to be 2.5, and the maximum mass a particle will have is 4. And then I just use a simple noise to spread that on top of it. I'll show that to you with a color node and ramp from attribute, mass 2.5 to 4, and if I just run it through this, there you go. So you see how I sort of have this breakup of mass between the particles. Like not all the particles are the same mass, and what this does is it gives the way my particles fall some variation. So they won't look like they're all falling uniformly, right? I did the same thing over here, and if I just plug this, I'll just turn this back to points. This was 0.5 to 1 and 0.5 to 1. There you go. You see how these top particles have much lower mass comparative to these mass, right? These particles. And what I did after that was I plugged both of these right into my popnet, right? Before we hop into my pop network, one last thing that I did was I actually used a trail node to compute the velocity for these buildings. Now, this is something that I've seen in my experience. Anything that I bring from Cinema 4D into Houdini, right, which is animated, the velocities are massive, right? The scale is massive, and so are the velocities massive as well. So what I usually do is I usually use a trail node, set it to compute velocity, and set my velocity scale down to 100th of what it initially came into, and then I just use a collision source. Uh, because over here I used a VDB reshape because these geometries were not thick, they were thin, and they would have created problems when it came to collisions. So I just ran them through a VDB reshape, made them thick, and just ran it through a file cache and converted all of these into good looking, high detailed VDBs for my collisions, right? Now, let's jump into my top network. Let me just lower the particle separation by quite a lot. And I think that would be fine. Okay, now let's jump into the DOP network. Now, inside the DOP network, it's pretty basic as to what. So if you just import a POP network, you'd find this in here, and that is pretty much exactly what I got in here. I'll go through all of these steps. They're not that difficult. Trust me, they're not. Trust me. The first thing that I did was I actually ended up using a static object node and just importing my buildings in here, right? I definitely should just name my nodes. Excuse me for that. And I think I think this should be, yeah, yep. This is definitely the buildings. I don't know. Yeah, there you go. So you can see this is definitely my buildings, and all I did was I just gave it the SOP path for the geometry, the geometry node which I created from my collision source, and the RBD solver to volume collisions. I set the mode to volume sample, and I just gave it a proxy volume of the VDB that I cached out. Now, if I turn the display geometry off and turn the collision guide on, this might take a while. You'll see this is what Houdini is going to read when calculating collisions, right? So it is important that this is cached out in as high detail as possible, right? Now, if I turn this back on, I did the same thing over here. Yep, I did the same thing over here for this geometry as well. So if I just turn this display geometry off and turn the collision guide for this on, you'll see it's the exact same thing as the buildings. Perfect. All right. Now, coming back to what I did for my particles, right? And you'll see that particles over here actually have four colors. One is the sand looking one, the other one is this bright, ugly green. You have these blue particles, and you'll see a red particle in here somewhere as well. Let me just turn this really quickly off so you don't get. There you go. Okay, now I'll explain what all of these are. But first of all, this is important. So my pop source, I set that to all points. Use my first context geometry. So if you come back here, the first context geometry is these particles, which are all the particles except the top layer, right? And yeah, and in the birth tab, what I did was I just had them activate on the first frame and on the first frame only. Otherwise, they'll just keep emitting, and I set my life expectancy to 100 so that they don't die, right? And this, just so you know, this is in seconds and not in frames. The next important thing that I ended up doing was I ended up using a pop awaken node. Now, what this node does is it ensures that not all of your particles are activated as soon as the simulation is run. And this is exactly why I had to use this over here. So once my simulation is started, all of my particles are at sleep. Like I'll show you what I mean. So if I just turn this collider off, right? And I just, oh, sorry, not that one. That is exactly why you should name your nodes. If I just disable this node and I run my simulation, too slow. Let me just lower the particle count down. There you go. That should be good enough. All right. If I just run this and you see that looks like a bug, but you'll see what you'll see is all of these particles which are sort of brown, they're static. They're not moving. Like it's like they're asleep, right? And that is exactly what my pop awaken node does. And this also helps with saving simulation times, right? Because this simulation was like pretty darn heavy. It took me like 6 hours to get this simulated. Not this one, but the high res one, right? And I just use the pop awaken node and I enabled awaken by volume. And what that tells Houdini is as soon as this volume that I provide this with comes in contact or close to the particles, they'll start, they'll be activated, right? The state of stopped would be disregarded and they would be activated. And the action would be set to awaken. I can actually do the opposite and put them to sleep as well, but that would not do anything in this case because they're already asleep. And when the volume is less than this, and this is just a scale that I ended up with through trial and error. So as soon as the volume for this building, right, this building breaches this threshold, the particles would be activated and they'd start moving, right? That is all that I did for my pre-solve, right? Now, coming into the post solve, what I did for my post solve is, first of all, I just set a generic color for all of my particles to be red, right? And you'll see what I mean by that. Uh, the second thing that I did was I create a pop group node, right? And I just used a simple vex code over here, an if condition that tells Houdini that all the particles that are stopped, just put them into a group called stop, right? Nothing else. Nothing complicated, no rocket science, just simple, pure, any particle which is asleep, just put it into a group called stop, right? And all the particles through a pop color node, all the particles that are in the group stopped, just give them this color, right? And just ignore this collision detect for now, but all the particles that are put to sleep or that are asleep already, just give them this color, and that is all that I'm doing, right? And that explains why you see the brown color and the the red color, right? So all the particles which are asleep are brown, and all the particles which are not asleep are red, right? Now, what are the blue particles? The blue particles are just from this pop collision detect, right? Which actually detects all the particles which are hit with this building and colors them blue. Now, I was actually experimenting with something. I didn't really end up using this hit group, but it could be advantageous in a few in some few scenarios. For example, if you're doing a rain simulation, it would be helpful in that scenario, right? Now, coming back, this I created as a second stream, right? And I just use a second context geometry over here because I'm plugging these top particles into this second context, into this second input, and everything else is the same. And I just used a pop color node to color the top particles green. Now, why did I do that? Was so when I simulated this whole animation, as you can see over here, right there, it's actually running. Uh, this one, not this one. I'll try and find another scene for you. Not this one. Maybe this. Yeah, so you probably cannot see that very closely over here, but what ended up happening was the particles that were actually on top of it, because all the particles were asleep, right? As the simulation started, the particles just at the top of it, because that is the particles you're noticing the most, they looked very static. So I wanted just a layer of particles on top of the slept particles that are just sort of, moving. And that is why I separated these top particles and treated them separately, right? As you can see, these particles, they don't have any state of sleep. So the state of sleep are only on the particles which are not part of the top particles group, right? So what happens is when the simulation starts, these particles, these green particles, they're constantly moving, right? As you can see, if I just scrub through this really quickly, oh, I know why this is running so slow. Let's just let it cook. I'll just cancel that, and my sub steps are cranked all the way up. Yep, there you go. Here when it does that, there you go. All right. If I just run through this, you'll see that these green particles are moving, right? And the brown particles, they're like all static, right? So that is exactly why I did what I did. I'll just put this back to its original settings. There you go. All right. And I just gave them a green color. And after that, I just gave them a pop grains node. Now, this node is important for the particles to actually start reading your p scale, right? Otherwise, they will not, and they'll sort of collapse onto each other. Yeah, and they'll sort of just collapse onto each other. This is important for them to start reading the P scale. And what I also ended up doing was I ended up playing with these values a little bit, right? And these are all dependent, number one, on the scale of your scene, and number two, on the sort of look that you're trying to achieve with your particle simulation. All right. Once that was done, I just gave them a pop track to, sort of just take the velocity off of them a little bit. I gave them a pop speed limit so that no particles sort of, just fly around and they sort of stay in their limits. And lastly, I just gave them a pop force node to, add a bit of turbulence and ran all of that through my pop solver. And what I ended up with was I'll show that you have a play blast rendered out. Uh, just 1 second. There you go. All right, this is what I ended up with. All right, there you go. And you see how in the beginning you see the layer on top of these particles sort of, just shift to give it a more dynamic feel rather than all of these yellow particles or these brown particles being asleep, right? And because of that mass, you see that variation in how the particles are falling, and they're not all following uniformly. They're sort of just following they have a bit of variance in there. Now, what I did after that was so after my this popnet, I just ended up using a blast node to sort of uh, separate my colliders from my particles. And after that, I just use a group delete to clean all the groups that I did not need, and an attribute delete to clean up all the attributes that I did not want. And these are the attributes that I wanted to keep. And I just cat my simulation out. Now, for this specific simulation, what I ended up doing was I ended up rendering out about 18 million particles, right? And the problem that I ran into was that my computer was actually unable to render these many particles out. Now, I use Cinema 4D and Octane to render these particles out, but my computer was not able to render these many particles out. So I had to bring the particle count down. Now, as troubleshooting, I could not increase my particle separation because that meant I ended up losing detail. And currently, I was working with just enough detail. I wouldn't say it was the ideal amount of detail, but it was just the right amount of detail. So I didn't really want to compromise on that. So I ended up finding a workaround for that, which I am going to show you right now. So what I ended up doing was I ended up so this I'll come back to later, right? What I ended up doing was I ended up plugging my simulation, right, uh, through a group node, okay? And over here in the attribute blur, where I just blurred the color of this terrain, I ended up using a second point warp, right, in which I used a value of -1. Now, if you remember, for my actual terrain, for my collision terrain, I used a value of -2. Over here, I used a value of -1. So it's not as deep as the actual terrain, right? And I used this very, yeah, I just gave this thickness and converted it into a polygon, into a VDB, and I use this terrain to sort of delete all the particles that are intersecting with the newly created terrain. And what that did was it gave me the same detail on the top of my particles, but it brought my particle count down by almost half, even more than a half, right? And what that does is it enabled my computer to sort of render faster. And, in this case, actually render it all. Because with that many particles, I wasn't able to render at all. Like my system would just crash, my render would just crash, right? Uh, okay, over here. Now, all of this is just a quick workaround that I had to do so I can actually import all of these attributes over here, right, into Cinema 4D and have Cinema 4D read them as well. Now, what I ended up doing was I just created an attribute randomize to sort of just randomize my orientation for the particles, right? So they're not all pointing in the same direction. This sort of just works like this works the same as the random attribute or the random effector inside of Cinema 4D. And I just created a simple height attribute which is equal to the position y. Oops, which is equal to the position y of the particles, and I just plug that into my original particle sim through an attribute transfer. And yep, this part is important. Yep. So this, you can just take a screenshot over here. This is all the particles that Houdini export. Sorry, these are all the attributes that Houdini exports, and these are the names of those attributes that Cinema 4D reads, right? And naming convention is important over here. The nomenclature is important over here because the problem is that if you don't do this and you export your particles out as an alembic, Cinema 4D would still read all of this, right? But it would read this as vertex maps, right? And what, from my experience, what I've seen is alembics with baked vertex map can be buggy when using with your MoGraph effectors. So what I mean by that is I'll actually show you what I mean by that. So for example, I'll just really quickly open up an alembic that I uh, created, right? So this is that alembic, right? And you see it creates all of these alembics, all of these vertex maps, right? Now I want to plug a cloner with a sphere. Uh, and I'll just set this to object, multi-instance, and plug this through. Oops, plug this and sorry, sorry, that is not how I want to import this. I wanted to import this as a particle group. There you go. And I'll just give this there. Now, what you see is that this is Cinema 4D 2025, by the way. This is importing these particles with a uniform radius, right? Now, but what I want is I actually want them to have a random radius. And what you'll see happens if I give it a random attribute and sort of just turn this off, scale 5 and scale this down by 1 and I'll set this to 1. What you'll see happens is that the scale sort of, just sticks. And what that does is you'll have problems with intersections and it just won't look as good. As you see, they're having intersection problems over here. They just won't look that good. So what instead this new Cinema 4D does, it actually creates this little particle scale inside of your cloner, and once you enable that to 100%, it actually scales the particles based on the p-scale value that you've output from here, right? So that is important. So if you're importing something from Houdini, sorry, if you're exporting something from Houdini with a randomized particle scale, this helps a ton. Okay. And yeah, that is pretty much it for this tutorial. And in terms of how I rendered this out, I just simply I'll just actually, matter of fact, I'll just open up the shot. Uh, I think it was shot 7. There you go. So I just simply imported that alembic as a geometry, and I ended up giving it these little parts that I created, these little if I just show them to you, they're like really, really small. Let let me just scale them up by 100. Yeah, I just created these little small fragments to, just break up the whole sand a little bit so it does not look that uniform. And I just plug this right into a cloner and set it onto multi-instance and rendered it out. And yeah, that is pretty much it. So hopefully you guys find this helpful, and feel free to shoot any questions that you might have in the comments. And thank you. Appreciate it.